I'm Athanasios Skentos. I'm an associate director at Jacobs Engineering. And the topic that I'm going to present today is production of geomorphological maps. Is GIS enough? So to begin with, I'm going to start with Simon Sinek's golden circle, but I'm going to do it a bit in reverse. So initially, I'm going to start saying what exactly is a geomorphological map. Second states the inner cycle is going to be how we actually create geomorphological maps. And at the center of it, we need to understand if GIS is sufficient on this whole process, or we still need all this field work that we are still doing from the last 100 years now. So let's start with the what, but before actually we start with the what, let's start with what geomorphological map actually is not. So geomorphological map is not a geological map, and also a geomorphological map is so much more than a topographic map. So now going to understand what it is. It's a map with no standards, just common principles. And we can simply say that a geomorphological map is representation of landforms, the outer shapes, underlying materials and formative processes. Sorry, I need to move that a bit. Yeah, cool. Okay. Okay, now let's go to the categories. There are two main categories of geomorphological map based on their content. So initially we have basic or analytical. We're talking about the holistic approach. The geomorphologist investigates all geomorphological aspects in order to capture all processes and landforms in a specific area, and therefore determine the evolution of the terrain. And also we have the derived or specialized. They focus on the tree and not the forest, like the previous one. So the cartographer actually focuses on a specific landform and process, investigating a specific subject, for instance, the landslides. We could also categorize geomorphological maps based on their scale. So it can be large, medium, or small scale. And we categorize them based on the scale because the size will define both the content and the map composition approach. So with regards to the data types, based on the common principles, there are 5 data types that one could expect to see on a geomorphological map. So we have the morphographic data, qualitative description of landforms. Then we have the morphometric one, which is the quantitative description of the shape of the landforms. We have the structural, anything related to geology. The morphogenetic, anything related to the process that form these landforms. And last but not least, the chronological, which is the time aspect about the landscape evolution. So it needs to be clarified that geomorphological mapping is not something new. The first geomorphological maps are more than 100 years old. However, as you can see on the table presented to you, the lack of universality and the complexity of the terrain on local and regional level led to various approaches on how a geomorphological map is created. So different schools, as you can see on the table, lead to different product visualization. This can be even more visible if we see Otto et al.'s figure. We can understand what exactly we described. As you can see, there are 2 specific landforms that are presented in so many different symbols following the rules established by each school. And of course, if we go to the maps, you can see that it becomes even more clear that if we don't have a legend, which is compulsory to every geomorphological map to be accompanied by a legend, no one can read actually a geomorphological map. So since we had a brief understanding of what exactly is a geomorphological map, then let's go and understand how we create a geomorphological map. So first of all, we need to have a strategy. What is the purpose of the geomorphological mapping? Is it going to be a basic one, as we said before, or should focus on specific geomorphological entities? Of course, scale is equally important. Then the cartographer needs to identify all the requirements for the geomorphological mapping. It should be noted that geomorphological mapping is a time-consuming activity with significant costs on the whole project. So after we have a preparation, then we have two activities: the field survey, the field work, and the digital mapping. Regardless the massive advance in GIS science, most scholars believe that fieldwork is still compulsory. So getting prepared for the site visit is really important since it minimizes risk and reduces the effort needed. So finally, we go to the digital mapping, which is the final stage for the map production. We have the data process, including the cleansing, management, and creation of secondary data using the spatial analysis libraries of the various GIS software like ArcGIS, QuantumGIS, ArcGIS. And of course, the final stage is the map composition. So I have a swim lane here. It's the methodology that I followed when I did my PhD thesis for creating a geomorphological map of the Ikari Island on the Aegean Sea. So how a scholar might work will vary from study to study, but each approach, as we already said, should try and capture the main 5 data we already described. So target was to create the geomorphological database from data derived by different routes. Therefore, by applying automated GIS techniques, I capture information from the high resolution digital elevation model related to morphography and morphometry. The manual process of digitizing the geological information from the analog geological map provided all data related to geology. So once the database is in place, then the landforms were identified. This was a semi-automated process, taking into consideration GIS automated techniques like TPI classification, conducting multivariate analysis by implementing if-else logic cases, and of course, a quality control by all information fed by satellite images fieldwork. So now we'll go to why. And the why, it's not why we still need geomorphological maps, but why GIS is not still sufficient for this one. So it's well known to everyone that GIS and remote sensing have evolved significantly. And we also know that fieldwork is both time-consuming and expensive. However, GIS is still not enough, and this can be summarized in 3 main reasons. First of all, we have lack of universality, we have graphical restrictions, and geomorphological knowledge is needed throughout the whole process. A competent GIS user cannot create a decent geomorphological map. I'll try to provide some examples to give more information than what I already said. So if we go to the terrain complexity, it's undoubtedly the main reason for not being able to have a standard common approach on geomorphological mapping. So what you see on your screen is an example of automated landform classification derived by combining 2 TPIs with a different values, small and large one, using Saga GIS. So as you can see, of these 3 hours going from west to east, by the shoreline, they have been identified. The first one on the west is a canyon. Then we go to a U-shaped valley, and the easternmost part, it says local ridges, hills, and valleys. So these landforms definitely do not make any sense, and the reason is quite simple. The tool that was implemented by Weiss and Jensen when studying mountainous environments, so they never took into consideration the coastal ones. So application on the coastal areas of the TPI was not successful, and therefore we have lack of universality. The funny thing in this one is that numerous scholars have used the specific index on coastal areas, presenting their findings in journals, conferences, doing all the statistical on the background without clarifying the coastal areas at all. So while I was working my PhD, I tried to identify the boundary of the coastal environment, like a polygon, using lidar data and slopes, so I could flag the coastal area, and therefore I made the TPI index, and make sure that if someone wants to use a coastal area, they can implement the amended TPI index and actually do that work. So I tried to apply the methodology in the nearby island, Ficaria, which has similar geology as well. The outcome was disastrous. Therefore, that's another example of lack of universality. To go further on the graphic restrictions, symbology is potentially the most important one. Regardless of geomorphology, I'm quite sure that every cartographer has faced the symbology limitation in GIS. So as you can see on the figure, trying to create geomorphological symbols, especially polylines, is extremely difficult. Try to understand the outcome of this figure. If you can imagine that it could be actually in an area covering, I don't know, 20 or 25 kilometers along a contour, just trying to show a cliff, you do understand that the symbol wouldn't be in the way that we want it to be. Lastly, we need to speak about the map readability as well. So as we already said, we have 5 main data types. We have morphometry, morphodynamics, chronology, structure, and genesis into a single map. So we're talking about really high information that actually most of the time results to poor legibility. This is not just on the symbols, but also on colors, textures, and the poor design properties that we are actually facing at the moment within the GIS software. So to sum up, there are no rules, standards, just some common principles on geomorphological mapping. The complexity of the terrain on both local and regional level leads to uncertainty when visualizing its history. There's no holistic approach to what we're doing at the moment. Geomorphologists do not follow the latest trends in GIS. That's another important factor. A really good geomorphologist, it doesn't mean that is a competent GIS user. And that goes also the other way. A GIS expert cannot and should not produce geomorphological maps. However, we've seen them doing quite a lot of work doing just specialized, derived geomorphological maps. And finally, the automated GIS techniques are currently encouraged only for derived specialized geomorphological maps. And that's it. Thank you.